The Fourier law is a fundamental principle that describes the rate of heat transferred through a material by conduction process. The law states that the rate of heat flow is directly proportional to the temperature difference and the area of heat transfer, and inversely proportional to the thickness of the material. The formula is Q is equal to negative K into A multiplied by dt by dx, where Q is the rate of heat transfer. K is the thermal conductivity of the material. A is the area perpendicular to the heat flow. Delta T is the temperature gradient and delta X is the thickness of the material. From the formula, it is evident that the rate of heat transfer is affected by various factors. First is temperature difference. The greater the difference between the hot side and the cold side, the faster the heat flows from one end to the other. Second is area. The larger the surface area perpendicular to the heat flow, like the bottom of a cooking pot, the faster the transfer of heat occurs. Third is materials property, also called as thermal conductivity. Materials like metals which have high thermal conductivity conduct heat quickly, while materials like wood or air having low thermal conductivity conduct heat slowly, acting as insulators. Last is thickness. The thicker the material, like a wall, the slower the heat flows. Fourier's law is a fundamental principle in thermal science. When combined with the principle of conservation of energy, Fourier's law forms the heat equation, which is the starting point for solving virtually every heat conduction problem in engineering and physics. Let's dive into some real-world uses of Fourier's law and see how it impacts our everyday lives. Engineers use Fourier's law to select low thermal conductivity materials and calculate the necessary thickness for insulation in buildings, refrigeration systems, and industrial pipes to minimize heat loss or gain and improve energy efficiency. Conversely, high thermal conductivity materials like copper, aluminum are used to design an efficient heat exchanger to facilitate rapid heat transfer. Also, Fourier's law is crucial for designing heat sinks and cooling systems in electronic devices, computers, smartphones, etc., to dissipate heat effectively, preventing components from overheating and ensuring optimal performance. Fourier's law helps in understanding and estimating heat flow in the Earth's or other planets' crust. Though in deeper layers, convection dominates. Fourier's law is useful in the medical field too. Principles of heat conduction are used in applications like thermal therapy and in the design of medical equipment where temperature control is critical. That's a wrap on Fourier's law. If you've got any questions, drop a comment below. Thanks for watching.